Hello, and you are welcome to Join Mathematics, a platform that seeks to establish understanding in mathematics. And my name is Ejalonibu David, and I will be taking you on the topic vectors. So stay with me. We are going to have a series of videos on this topic where we'll establish understanding on what it means to have vectors, scalar product of vectors, vector products, and all other things necessary to gain understanding on this topic. Now let's begin. The first thing we are going to look at is what we call physical quantities. Now, we know there are two kinds of physical quantities. We have the scalar quantities and we have the vector quantities. Now, the scalar quantities are what we know that have only magnitude, while the vectors have both magnitude, and direction. Now, take for instance, we have a line AB. Now, if we are given that the line AB is of length 10 kilometers. Now, this has only a magnitude of length, and if the vectors, however, will have a direction that the line is moving from A to B, so we will have it that A moving towards B with a length of 10 kilometers. Now, what distinguishes a scalar from a vector is the direction. So physical quantities which have only magnitude are called scalars, and physical quantities that have both magnitude and directions are called vectors. So what are the examples of scalars? Scalar quantities include we have length, we have area, we also have volume. These are scalar quantities. We have mass. We can also have work energy. Speed is a scalar quantity. And in the same vein, we have vector quantities. The vector quantities include displacement. Displacement. We have velocity. You can see speed. Both can have the unit of kilometer per hour, meter per second. Velocity can also have the speed of kilometer per hour and also meter per second. But what distinguishes speed and velocity together is the direction. Speed doesn't have direction, velocity has direction. Same thing with length. Length can be meters, centimeters, kilometers, and the same thing with displacement: meters, centimeters, kilometer. However, the length here doesn't have direction, but the displacements have direction. So other examples of vector quantities include acceleration with the unit of meter per second squared. We have force with the unit of Newton, and we have momentum. Now, what are the types of vectors? If we have examples of vectors, what therefore are the types of vectors? Now, in this case, we have so many types of vectors. We can have position vectors to start with, which will be our main focus. We have position vectors. We can also have displacement vectors. Number 3, we can also have line vectors. We have free vectors. We have zero vector. And we also see scenarios of unit vectors. And finally, we can have something called a negative vector. So we have seen the definition of vector. It has magnitude and direction. We have seen the various examples of vectors. compared it to the examples of scalar, and then we move to the types of vectors. Now we would notice that we'll be dealing more of position vectors. However, towards the end of the video, we'll be seeing more of the other types of vectors, especially the unit vector. Now, in our next video or next lesson, we will take a look at vector representation. How then can we represent vectors? We know that the vectors have magnitude and direction. How do we represent it?